Bismillahirrahmanirrahim. This is a question, October 10, 43, variant question number 3 in worksheet 49 number. So let's see what a question mentioned here. If you see, there's a right angle triangle, 30 given, 90 given, okay? And this is most important in this question, first part to find tension. But this sentence is a very, very important, students. Given that resultant force exerted on the pulley. This sentence very important. On the pulley by the string. On the pulley by the string. That means this string, due to weight hanging, this string is pushing the pulley downwards. You can see how this way downwards. And in the reaction, this pulley will push the string outwards like this. And this is called R. Okay. And what is this value is 3 root 3. So this is also 3 root 3. And we have a special formula for it. And what is that formula? Formula is 2R. Sorry, R is equals to 2T cos alpha divided by 2. Okay, so this R I am showing here. Actually, this component, they are balancing, okay? So, and this is 30, this is 90, and this angle is alpha, which is 60. So this 60 can go here, and this value can go here, and we can find the tension. So 3 root 3, 2t cos 60 divided by 2. So cos 60 by 30, cos 30 is root 3 by 2. If you type in calculator. So this 2 will cancel with this 2, this root 3 will go under it, and they will cancel out. So ultimately tension becomes 3. So just for your clarity, I just give you this concept here. So just have a look here. We have a look at here, one basic criteria: tension towards pulley, tension towards pulley, and tension towards pulley, and tension towards pulley. This one basic idea I given, extra knowledge, and tension is always equals to each other. Okay, there's a very clear. All right, because basically we have one string only, that is why. Okay, there are no two strings, that is why tension. And second number, this R is a push, the force exerted by the pulley on the string. Same here, R, pulley is pushing upwards the string. Same here, R is, so pulley is pushing upwards, so on the string, this R. Same here, R. So formula, basically we have this. Okay, R2T, R is equal to T cos alpha by 2. So three variable R, T, alpha give use in this formula. Any two given, third we can find. So in this question, R given and alpha given, we can find T. Sometime he can give you R and T if we need an angle alpha. So I think this point is very clear. But so whenever normal reaction of the pulley on a string or string on the pulley given, we can use this formula which is mentioned here. So let's go for the question now. Now, what the first part is done, part number 1 is over. Part number 2, he said that coefficient of friction is given 0.75. Okay, so now I'm resolving the forces and mentioned that given Q in equilibrium and point of slipping, find its mass. So we have to find it. So first of all, because system in equilibrium, okay, let's start one by one. So this force, this is what is called 10 m. If mass is m, let's say this mass is m, all right, or given p particle, I think not m1, I call it a p. So this mass is a p particle and mass is, let's say, m1, I give a name. So this is a 10 m1, okay, and tension towards pulley, that always equals to each other. And what about the other particle? Other particle is a q. This is a q particle, and q mass, let's say, take m2. If m2 mass, so weight component become 10 m2. So what is this? 10 m2 sine 30. I think clear. All right. And what about this, students? 10 m2. Sorry, this is r. This is r. This is a normal reaction. Okay. And what about this? 10 m2 cos 30. Now I can do my question easily because all concepts are clear. So let's start. How we're going to continue part number 2. First, I talk about p particle. So I'm writing p particle. According to situation, what's formula? net force is equals to ma. Okay, but thing is that here friction is very important. That is one. Look at here about on the point of moving up. This is very interesting. Q is about to move up. I repeat my words. Q is about to move up. So this is I'm writing the word about to move up. So friction naturally will be downwards. So this is the most important part of chapter of the other question where students confuse. It means this about to move down naturally. Okay. So net force. So this is bigger, not bigger we can say, but some extent bigger. So I can say that what is the basic formula? Net force equals to ma. So I can say this component minus this component because two forces acting on a p particle, one downwards, one upwards. So I can say 10 m1 minus tension equals to mass is again m1 times 2 acceleration, that is 0. So it means I can say here tension is okay, 10 m1 and tension is given by him is 3 now. So minus 3 equals to 0. 3 goes on the other side and 10 divides. So congratulations students, I got m1 is very clear 0.3 kilograms. Okay, and although maybe he's asking for m1 or not, anyway I found it. Now let's go for the but I think he's asking for the q, okay, and not for the p. This is extra work done, no problem. Let's go for the p because he talked about q and the 0.75 is given by him. So what is a f is equals to mu r, and all of you know f we can find from here. What is the mu, students? Mu 0.75. So I'm writing here 0.75 and r is what? R is equal to this one. So I'm writing here 10 m2 cos 30. And cos 30 is actually equals to is a value. So 10 times to this, I get 7.5 m2. And this is a root 3 by 2 because its value we know it. It is not important to write, but anyway, it's make easy. Now, students, I can make an equation for it. And what the way I make here for P and same for Q. And for Q, actually this work I have done just extra. Okay, Q Q particle, sorry, net force equals to ma. Basic formula we use because about to move upward, students. So this force is bigger. So tension minus friction minus weight component equals to 0. So let's start. Tension minus friction minus weight component is 10 m2, 10 m2 sine 30 equal to 0 because acceleration 0. Okay, now tension because we have a 3. Okay, 3 and this value we know it did. So best idea, okay, I'm putting it 7.5 m2 into root 3 by 2 and minus 10 m2 sine 30 is a half. Actually I'm writing half, which is cancel out 5 to 1 are 2, 2 5 are 10. So this is clear. And now there are two m2s are there. I'll bring both because both signs are negative. I leave 3 alone here and bring rest values on the other side. So 7.5 times to root 3 by 2 m2 and minus 5, not minus, plus 5 m2. So from here m2 is common. So 7.5 into root 3 by 2 and plus 5 m2. So this whole thing will divide under 3 and I'm typing in my calculator. So 1 minute student, 3 divided by 7.5 into root 3 and divided by 2 and plus 5. And answer is coming with me as M2 is coming 0.26097, which I rounded. If I get it round because I know 3SF this, I don't want the bigger than 4, yes, add. So 0.261 kilograms is our answer. And I believe you got a point very, very clear.